Welcome to another deep dive. We've been getting a ton of questions from you about AI and how it relates to psychology. So we're diving into that today. It's pretty amazing to think about how AI is giving us these brand new ways to understand the human mind.
It really is. We've gathered a pretty incredible amount of material for this deep dive. We're talking academic papers, industry reports, all the latest research findings, all of it focusing on how AI and psychology can work together.
Exactly. And our goal is to break down the most important takeaways for you. We'll be looking at how AI is being used in psychology to analyze how we talk, to find patterns in our behavior, to interpret all those nonverbal cues we give each other, even to build models of how we think and decode what's going on in our brains. Get ready to learn about some surprising ways AI is helping us figure out why we do the things we do. Where do we even begin with all of this?
Well, I guess since it's so central to being human, maybe we should start with language. AI is offering some really interesting insights for psychologists through something called natural language processing, or NLP for short. It's helping us understand not just what we say, but how we say it.
Okay, NLP. So how does AI actually analyze language? How does it work?
So there are three main approaches that our sources highlight. The first one is lexicon-based methods. Basically, they rely on these predefined dictionaries or lexicons where each word is associated with a particular emotion or a sentiment score. Think of tools like Vader, AFN, and the NRC Sentiment Dictionary.
Okay, so you've got these lists of words, and each word has a feeling attached to it, like joyful gets a positive score and anxious gets a negative one. You feed some text into the system, and it just counts up the emotional words to figure out the overall sentiment, right? That seems pretty simple.
Yeah, it is pretty straightforward, which makes it easy to understand, but it also has limitations. It can miss a lot of context, like think about sarcasm, where you say one thing but mean the opposite, or when emotions are implied and not directly stated. Those things can really trip up lexicon-based methods. And human emotion is just so complex, you can't always capture it with just word counts, right? The system will assign a sentiment score to each word that it recognizes and then combines those scores for the whole piece of text.
Right. It's a good starting point, but misses the finer points.
Okay.
So what's the next level of complexity?
That would be machine learning-based methods. Instead of relying on predefined dictionaries, we train statistical models on a ton of text data that humans have already labeled with the correct sentiment or emotion. Things like naive Bayes or support vector machines.
So it's learning by example. Like if it sees a bunch of sentences labeled happy that have certain words or phrases, it starts to connect those features with happiness.
You got it. It finds the patterns. It might notice that certain words always pop up together when someone is expressing sadness, or it picks up on phrases called engrams that usually mean a certain emotion. It's like the AI learning phrases like feeling down or really stressed instead of just individual words. Because it's picking up on these complex patterns in the language, it can be more accurate than just counting up words. But of course, you need a lot of good, quality labeled data to train these models properly. The training process is super important. You feed it tons and tons of examples so that it can statistically link certain ways of using language to certain emotions.
Got it. More data, more complexity, and hopefully more accurate results. Now, what about those super advanced AI systems we hear so much about? The ones that seem to understand language almost like a human does? Isn't that where deep learning comes in?
Yeah, exactly. Deep learning methods utilize artificial neural networks. Things like convolutional neural networks, or CNNs, recurrent neural networks like those LSTMs and those really powerful transformer models, BERT and GPT. These can learn what we call hierarchical representations of language. Basically, they learn in layers, starting from individual words and going up to phrases, sentences, and then the full meaning, kind of like how you build up your understanding of a story. This lets them understand context and nuance much better. They can even figure out the connection between words that are far apart in a text.
So they're not just looking at isolated words or small chunks of text, they're understanding how ideas connect across an entire paragraph or even a whole conversation.
Yeah, that's a major strength. They pick up on those subtle connections that really give language meaning, and they're achieving some pretty impressive results when it comes to tasks like figuring out the emotion behind a text or analyzing the overall sentiment. But one thing our sources pointed out is that they can be kind of like a black box. It's tough to figure out exactly why they come to a certain conclusion. They process text through so many layers, and the transformer models use these things called attention mechanisms, which basically let them zero in on the most important parts of the text. It's like, how you might highlight the key words in a sentence to understand the main idea. Transformer models are doing something kind of similar.
So they're learning to focus on the words that really carry the weight of the message. Pretty amazing, but it can make it a bit harder to follow their reasoning. With all these tools to analyze language, how are psychologists actually using them in their work?
There are so many cool applications. One of the main ones we've talked about is sentiment analysis, and you can use this in all sorts of ways, like understanding customer reviews for products or figuring out public opinion on important mental health issues by looking at what people are saying on social media. And even in therapy, you can use it to track the emotional tone of therapy sessions over time, which could give therapists really valuable insights into how their patients are progressing.
Using AI to track the emotional journey of a therapy session, that's really interesting. But what about going beyond just positive or negative feelings? Isn't that where emotion detection comes in?
You got it. Emotion detection focuses on identifying specific emotions like joy, sadness, anger, fear, all the basic emotions within a text. This is super helpful for understanding emotional responses to all kinds of things like how people react to different stimuli in experiments or how to design human-computer interactions that are more intuitive and responsive. There's even potential for using it to help diagnose mental health conditions by finding patterns of emotional language that might point to a specific disorder.
And I know our sources talked about using NLP for something really important, which is the early detection of potential mental health crises. How does that work exactly?
So NLP tools can look for clues in the language people use, especially on social media. They look for things like expressions of hopelessness or if someone's talking about suicidal thoughts. This could give us early warning signs so we can get people the help they need sooner. Think about how crucial that could be. It could literally save lives and help us shift towards a more preventative approach to mental health care.
That's really powerful. It can make a huge difference. Now, switching gears a bit, can AI actually tell us anything about someone's personality just by looking at the way they write?
Yeah, that's another fascinating area of research. NLP can be used to try to figure out personality traits, especially those big five traits: openness, conscientiousness, extroversion, agreeableness, and neuroticism. By looking at the specific words someone uses and their overall writing style, both the lexicon-based methods and those more complex machine learning models can identify patterns that tend to correlate with those personality dimensions.
So, like how I write an email or a social media post could give clues about whether I'm more outgoing or introverted, organized, or spontaneous.
That's the idea. And this approach doesn't require any special tests or anything. It can be used on a large scale, which opens up some really interesting possibilities for things like finding the right people for jobs or even giving people more personalized recommendations based on their likely personality.
Wow, that's pretty wild to think about. And I remember reading something about cognitive complexity and communication styles as well. How does NLP fit into that?
NLP can analyze features of someone's writing or speech that might tell us how abstractly they think, how big their vocabulary is, how complex their sentences are, and how they use those little connecting words and phrases, the discourse markers.
Yeah.
This can give us a lot of insight into their thought processes and how they usually interact with other people.
So depending on the specific question I want to answer, the data I have, and whether I need to know why the AI is giving me a certain result, I need to choose the right NLP method. It seems like there's a trade-off between keeping things simple, getting accurate results, how much data I need, and how transparent the whole process is.
Right. Researchers have to think about all of those things carefully to pick the best technique for their research goals.
Okay, so NLP is all about how we can use AI to learn about psychology through language. But what about when psychologists want to find patterns and make predictions using all sorts of other data? Isn't that where machine learning in general comes in?
Exactly. Machine learning, or ML, is all about giving computers the ability to learn from data without us having to program them for every single specific task. It's becoming more and more important in psychology for finding those hidden patterns in data and making predictions about human behavior.
And I know there are different types of ML algorithms. Can you break those down for us?
Sure. The first major category is called supervised learning. This is typically used for prediction, where you've got labeled data. This means you know what the input features are, and you also know the corresponding output you're trying to predict. Like, let's say you want to predict whether a particular therapy will work for a patient based on their initial characteristics. You'd use algorithms like linear regression, logistic regression, decision trees, random forests, support vector machines, and even neural networks for this type of problem.
So you feed the algorithm a bunch of data about a patient, like their symptoms, their medical history, maybe some demographic information. And you also tell it whether or not the therapy worked for each person. Then, the algorithm learns the relationship between those features and the outcome. so it can predict the likelihood of success for new patients.
Exactly. Now, the second type is unsupervised learning. This is really helpful when you don't have labeled data, and your goal is to find hidden patterns or structure in the data. Techniques like k-means clustering, hierarchical clustering, and principal component analysis are common examples. And one that's especially useful in psychology is latent Dirichlet allocation, or LDA.
LDA, was that?
LDA is a way to figure out the topics or themes hidden within a large collection of text. The idea is that each document is like a mix of several underlying topics, and each topic is characterized by a certain set of words. By looking at which words tend to appear together most often, LDA can automatically find those hidden themes that you might not notice just by reading the text. It's super useful for understanding the key concepts in a field, identifying important psychological constructs, and even spotting new trends in research. So let's say you have a massive amount of interview transcripts. LDA can help you automatically figure out the main topics people are talking about. It's all based on how often words appear together to reveal those hidden thematic structures.
That sounds incredibly helpful for making sense of a ton of qualitative data. What about the third type of machine learning you mentioned?
Oh, right. That's reinforcement learning. It's a bit different. Here, we're training these things called agents to make a series of decisions in a specific environment. We do that by giving them rewards for doing the right thing and penalties for doing the wrong thing. It's not as widely used in psychology as the other two types yet, but it's becoming more popular for modeling how we make decisions in dynamic situations, how we learn new behaviors, and even for developing adaptive therapies that can adjust to a patient's needs in real time. It's pretty cutting-edge stuff.
So, just like with NLP, the choice of which machine learning approach to use depends on the specific questions a researcher is asking, right? Whether they're trying to make predictions about known outcomes, discover hidden patterns, or model how we make decisions over time.
Absolutely. The research questions drive the choice of the best ML strategy.
We've talked about AI analyzing language and machine learning, finding patterns in all kinds of data. But what about how AI can help us understand all those little nonverbal cues we're always giving each other, the ones we're often not even aware of? That's where computer vision comes in, right?
That's right. Computer vision is a branch of AI that lets computers see and interpret visual information from images and videos. It's turning out to be a really valuable tool for analyzing things like facial expressions and body language, which often tell us more than words ever could.
So how does a computer actually see and interpret a fleeting facial expression? What's the technology behind that?
It involves a few key steps. First, they use image and video processing techniques to find and track faces within the visual data. Once they've got a face, they use feature extraction methods to identify the key landmarks, like the corners of the mouth, the shape and position of the eyebrows, the lines around the eyes, that sort of thing. And they also analyze broader body movements. Then they use deep learning models, offshore convolutional neural networks, CNNs, and recurrent neural networks, RNNs, which are trained to classify those facial movements and recognize different types of body language.
So they're taking a complex visual signal, breaking it down into measurable parts, and then using AI to categorize those parts into meaningful psychological categories. And one of the main applications of this is automated emotion recognition, right?
Exactly. You can train AI to classify basic emotions like happiness, sadness, anger, fear, disgust, and surprise just by analyzing someone's facial expressions in a picture or a video. There's even some really fascinating research going on about detecting microexpressions. Those are super subtle, often unconscious facial movements that can sometimes reveal emotions people are trying to hide.
That sounds incredibly useful in situations where people might not be totally honest about how they're feeling. Yeah, I remember reading that cultural differences can have a big impact on how we express emotions non-verbally. How does AI deal with that?
That's a really important point. Our sources emphasize that for AI models to work accurately across different cultures, they need to be trained on diverse data sets that reflect the unique ways emotions are expressed in different parts of the world. Even basic emotions can be shown through facial expressions that have subtle but important differences between cultures. If you train an AI model mostly on data from one culture, it might misinterpret or even totally fail to recognize expressions from people from other cultures. So, to develop truly reliable emotion recognition systems, you absolutely need to use diverse training data that captures the full range of human expression. You can't assume a smile means the same thing or looks exactly the same everywhere.
That makes sense. You have to account for all the different ways people express themselves. So beyond recognizing basic emotions, how else is computer vision being used in psychology?
It's being used a lot for detailed behavioral analysis and experiments. AI can analyze things like subtle changes in posture, if someone's leaning forward or back, if they seem open or closed off, different gestures like hand movements or fidgeting, and even patterns of eye contact or the lack thereof. All these nonverbal cues can give us clues about someone's emotional state, their intentions, and other psychological stuff, especially when you're trying to understand social interactions or what's happening in therapy sessions. So instead of a researcher having to manually code hours of video footage, AI can automate the process and might even pick up on subtle things that a human observer could miss. These AI algorithms are trained to recognize body postures, gestures, and gaze patterns that have been statistically linked to specific psychological states. This allows for much more efficient and detailed analysis of video data. Computer vision is also being used to track eye movements really precisely, which gives researchers valuable data on attention, cognitive processing, and emotional responses to different stimuli. And there's this new thing called automated facial expression coding, or AFEC, which is really changing the game. These systems combine computer vision and machine learning to code facial expressions in real time, which cuts down a ton of time and effort for researchers.
So it sounds like computer vision is giving us a much more precise and objective way to study all those unconscious signals we're constantly sending with our bodies and faces.
Absolutely. It's opening up a whole new world for understanding the nonverbal side of our psychological experience.
We've covered how AI can analyze language and visual cues, and how machine learning can find patterns in all sorts of data. But AI is also being used to directly build models of how we think, those complex cognitive processes that drive our behavior. Tell me more about that.
This is really cutting edge stuff. We're seeing more and more use of AI to create computational models of things like memory, attention, and decision making. The basic idea is to simulate these processes on a computer to get a much deeper understanding of how they actually work in the human mind.
I read something in our research about generative AI being used to model memory and even imagination. That sounds almost like science fiction.
It is pretty futuristic. Generative AI models, especially these powerful generative neural networks, can learn from huge data sets that represent all our different experiences. Once they're trained, they can generate brand new but plausible experiences, or even recreate parts of past ones. This offers some really interesting explanations for things like why our memories sometimes get distorted or why we might remember things differently than how they actually happened. It supports the idea that memories aren't just recordings, but are actively reconstructed each time we access them. These AI models of memory often have components that are based on actual brain structures involved in memory, like the hippocampus and the neocortex. By training them on tons of simulated experiences, researchers can compare their performance, including their memory errors, to what we see in human memory. This can help us figure out the underlying neural processes involved in how we encode, store, and retrieve information.
So it's not just about remembering facts. It's about understanding the whole dynamic process of how memories are formed, how they change over time, how they're stored in the brain, and how we retrieve them.
Yeah, exactly. AI is also really useful for building computational models of attention. These models are often based on psychological theories about how we focus on certain things and ignore distractions. They try to simulate this selective attention process, and they even factor in things like surprise or motivation, which we know can influence what we pay attention to. So these models can help us understand not just what we pay attention to, but why. They give us a framework for understanding the mechanisms of attention and how things inside us and in the world around us can affect our focus. Some of these models even simulate how different pieces of information compete for our limited attention and how our goals and past experiences influence what we choose to focus on.
That's so fascinating. What about AI and decision-making? Our sources mentioned that too.
Yeah, AI is being used to create more and more sophisticated models of how humans make decisions. These models can include things like uncertainty, how we gather evidence before making a choice, and even those cognitive biases that can sometimes lead us to make less than rational decisions. These AI models are really useful for testing theories of decision-making and understanding the cognitive processes behind our choices. And this research could even help us design AI systems that better understand how humans make decisions, leading to more natural and effective interactions between humans and AI. These models often simulate the steps involved in making a decision, from evaluating options and thinking about potential outcomes to actually making a choice based on rules or criteria they've learned. AI's computational power lets us create much more complex and realistic models of these processes than we could before.
So we're basically building digital versions of our own minds to try to understand ourselves better.
In a way, yeah. It's about using computers to create systems that let us explore the complexities of human cognition in ways that we couldn't do before.
We've talked about how AI can analyze language and vision, how machine learning can find hidden patterns, and how AI can even model our thought processes. But it's also doing amazing things when it comes to understanding what's going on inside our brains, particularly through the analysis of neuroimaging data like fMRI and EEG.
Right. AI algorithms are really changing how we analyze neuroimaging data. They can help us identify complex and subtle patterns of brain activity that are linked to specific psychological states and processes, which is opening up so many new possibilities for understanding how the brain and mind are connected.
So instead of researchers just looking at fMRI scans or EEG readings, AI can help them uncover more nuanced patterns of brain activity that might be related to certain mental states.
Exactly. Machine learning and deep learning techniques like convolutional neural networks, CNNs, recurrent neural networks, RNNs, support vector machines, SVMs, and even newer ones like vision transformers, VITs, are being used all the time for pattern recognition in neuroimaging data. These AI models can automatically learn those super intricate spatial and temporal patterns in brain activity, which is really powerful for a lot of different tasks. This includes classifying different brain states, predicting how well someone will do on cognitive tasks, finding potential biomarkers for neurological and psychiatric disorders, and even trying to decode the neural activity that corresponds to specific thoughts and feelings.
It sounds like AI is helping us to understand the language of the brain. Do you have an example of how this is being used to understand psychological states better?
There's some really interesting research where AI is being used to analyze fMRI data to pinpoint specific brain regions and neural networks that are associated with different emotions, thoughts, and behaviors. Researchers have even shown that AI can predict how emotionally relevant someone's spontaneous thoughts are just by looking at activity patterns in brain networks that are involved in attention, emotional regulation, and self-reflection. This is a really exciting area because it suggests that AI could help us map the neural basis of our inner mental world. By training AI on fMRI data that's connected to people's reports of their thoughts and feelings, we can start to untangle the complex relationship between brain activity and conscious experience.
That's mind-blowing. So you're saying AI could potentially read our emotional thoughts just by looking at our brain activity.
Well, that's a simplification, but it does get at the incredible potential here. AI is also playing a crucial role in helping us identify the neural correlates of various mental health disorders, like autism, schizophrenia, and Alzheimer's disease, by looking for characteristic patterns in fMRI and EEG data. For example, AI has been really good at analyzing EEG data to find patterns that are linked to conditions like depression and schizophrenia. This could help make diagnoses more accurate and make diagnostic tools more accessible. A lot of these disorders have unique patterns of brain activity that show up in neuroimaging, and AI can be trained to recognize these patterns, leading to more automated and objective detection and diagnosis.
So it's not just about diagnosing these conditions, but also about understanding what might be different in the brains of people who have them.
Exactly. AI is also being used with more advanced techniques to interpret those complicated patterns of brain activity and connectivity. For example, it can analyze functional connectivity patterns in fMRI data, which basically means looking at how different parts of the brain interact and how those interactions might be different in various disorders. It can even be used to automatically interpret the background electrical activity in EEG recordings, which is super important for diagnosing certain neurological disorders.
It sounds like AI is giving us a totally new and incredibly powerful way to look at the human brain and its connection to our mental lives.
It really is. We're finding subtle patterns and making connections that would be incredibly difficult, if not impossible, to do using our old methods of analysis.
We've seen how AI can analyze data, find patterns, and even model how we think. But what about AI actually interacting with people directly to provide psychological assessment and support? That seems like a field that's really taking off.
You're right. There's a ton of work going into developing and testing AI-powered tools like virtual agents and therapy chatbots for psychological assessment and mental health support. These tools use AI to create interactions that can feel surprisingly human.
How do they actually build these AI therapy chatbots? It can't just be a fancy question and answer system, right?
Oh, it's much more than that. While some simple chatbots might use predefined dialogue options and decision trees, the more advanced ones use sophisticated AI, like natural language processing. Some even have these layered architectures to handle the complexity of the interactions. And a big step forward has been the use of large language models, which let these chatbots give more personalized and adaptive responses. These advanced systems can really simulate human-like conversation and tailor therapy to the individual user. They use natural language understanding to figure out what the user means and natural language generation to create responses that are empathetic and relevant to the conversation.
So they're not just giving pre-programmed answers. They're actually trying to understand what you're saying and responding in a more natural way.
That's the goal. And there have been a bunch of studies looking at how effective these AI tools are for providing mental health support and doing assessments. Some studies have even shown that people who use these chatbots experience significant reductions in symptoms of depression and anxiety. There's even some early evidence suggesting that these chatbots can lead to similar improvements in symptoms as traditional therapy, at least in some cases. That's really promising because it means these tools could help more people get access to mental health support and reduce the stigma around seeking help. These chatbots often use evidence-based approaches like cognitive behavioral therapy, CBT, and can provide personalized feedback to the user.
That's encouraging. It seems like AI could be a big help in reaching people who need mental health support. But what about those subtle aspects of human communication, especially when it comes to complex emotions? Is AI ready for that?
That's the million-dollar question, and it's definitely still a work in progress. AI has come a long way, but truly understanding and responding to the full range of human emotions, with all their nuances, is still a challenge. But researchers are working hard to make AI better at detecting and responding to these subtleties.
It sounds like there's huge potential here, but we're still figuring out how to refine these AI tools and understand their role in providing effective support.
I think that's a really good summary. It's a fast-moving field, and we need to keep doing research and testing these tools carefully as we move forward.
Looking ahead now, what are some of the most exciting emerging trends and future directions that you see in the world of AI and psychology?
Well, the field is moving so quickly. There are a ton of exciting developments happening. One thing we're definitely seeing is the development of AI models that are much better at understanding and responding to human emotions in a nuanced way. We're also seeing more and more integration of AI into things like wearables and mobile health apps to provide continuous and personalized mental health monitoring and support.
So people could potentially get help and support right when they need it most based on real-time data.
Exactly. And in the future, I think we'll see a much stronger focus on using AI to develop personalized therapies that are tailored to each person's unique needs and psychological profile. This could involve adapting the content of the therapy, when interventions happen, and even how the therapy is delivered, all based on real-time feedback and AI analysis of the person's responses.
Wow, so we're moving towards a much more individualized and adaptive approach to mental health care.
Right. And from a research perspective, these advanced AI models could help us understand the human mind in much deeper ways. AI is a powerful tool for testing and refining our current theories about how we think, feel, and act, and for discovering new things about the human mind. This includes developing even more sophisticated models of basic cognitive processes like memory, attention, and decision-making. So AI isn't just about creating practical tools, it's also a powerful engine for scientific discovery in psychology.
So it's not just about building better tools, but also about understanding what it means to be human on a deeper level.
Exactly. We're also likely to see more multimodal AI approaches in the future, where multiple types of data are combined and analyzed together. This could include text, voice recordings, images of faces, and physiological data from sensors. By combining all these different data streams, we can get a much more complete and accurate picture of a person's psychological state. This could dramatically improve things like emotion recognition and the diagnosis of mental health conditions. Imagine systems that can analyze how you're speaking, your facial expressions from a webcam, and your physiological signals from a smartwatch all at the same time to provide a truly holistic assessment of your well-being.
The possibilities for AI in psychology seem almost endless.
They really do. It's a field that's advancing so rapidly, and it has the potential to completely change how we understand the human mind and how we approach mental health and well-being.
This has been an incredible deep dive into the fascinating world where AI and psychology meet. We've explored how AI is changing how we understand things, from analyzing the subtle ways we use language, to recognizing emotions on people's faces, to building models of our thought processes, and even decoding the complex activity of our brains. AI is clearly a game changer for both advancing psychological science and making mental health care more accessible and effective.
As we've seen, the advancements in AI are opening up amazing opportunities to learn more about the human mind and develop better ways to support mental well-being.
Absolutely. And on that note, here's a final thought for you to ponder. With AI getting better and better at understanding and even predicting human thoughts and emotions, what new doors might this open for us when it comes to understanding ourselves and growing as individuals? It's a question that's going to become even more important as this field keeps evolving. Thanks for joining us for this deep dive.